Here's a shocking truth that will change how you think about the ocean forever. Those legendary monster waves that have terrorized sailors for centuries aren't supernatural anomalies. They're just Mother Nature having an absolutely terrible day. Picture this nightmare scenario from New Year's Day 1995. An colossal 80-foot wall of water comes crashing down on the Dropner oil platform in the treacherous North Sea. This aquatic beast didn't just splash around. It twisted steel railings like paper clips and hurled massive equipment across the deck as if they were toys. But here's where it gets fascinating. This devastating encounter became the first time scientists actually captured hard, measurable data of a rogue wave in the wild ocean. This single event validated centuries of sailor testimony, explains Francesco Fedele, an associate professor at Georgia Tech's School of Civil and Environmental Engineering. Maritime veterans had been reporting these sudden, gigantic waves for generations, but the scientific community dismissed their accounts as maritime folklore or exaggerated fish tales, overturning scientific dogma. That one massive wave didn't just damage an oil platform, it shattered scientific assumptions and ignited nearly 3 decades of heated academic debate about how these oceanic giants actually come to life. Fedele, who had been questioning mainstream explanations for years, assembled an international research team to dig deeper into rogue wave mysteries. Their groundbreaking findings, recently published in scientific reports, represent a seismic shift in ocean science understanding. The research team meticulously examined an unprecedented 27,500 wave records spanning 18 years in the North Sea, creating the most exhaustive database of real-world wave behavior ever assembled. Every single record documented 30 minutes of intricate wave behavior, tracking height measurements, frequency patterns, and directional movements with scientific precision. Their discoveries completely upended established scientific beliefs. Here's the controversial part most people miss. These towering liquid skyscrapers don't need mysterious or exotic forces to materialize. They simply require ordinary ocean mechanics to align in just the wrong way at just the wrong moment. Rogue waves operate within nature's standard rulebook, not outside of it, Fedele emphasizes. This represents the most conclusive real-world evidence we've ever gathered on this phenomenon. Mundane physics, extraordinary results. For decades, the scientific establishment has championed a theory called modulational instability to explain rogue wave formation. Think of it like this. Imagine small timing and spacing variations between waves, causing energy to concentrate dramatically into a single wave, rather than energy remaining evenly distributed across multiple waves. The entire pattern reorganizes itself, allowing one wave to suddenly balloon far beyond its neighbors. But here's where Fedele drops a scientific bombshell. Modulational instability works reasonably well when waves are trapped within confined spaces, such as laboratory wave tanks, where energy can only travel in one specific direction. However, in the vast expanse of the open ocean, energy disperses in countless directions simultaneously. The data tells a different story. When Fedele's team dove deep into their massive North Sea dataset, they uncovered something that challenges everything we thought we knew. They found zero evidence supporting modulational instability in actual rogue wave formation. Instead, they discovered that these oceanic monsters result from two much simpler, more predictable phenomena working in tandem. First, linear focusing occurs when waves traveling at different speeds and from various directions happen to converge at exactly the same location and moment in time. Picture multiple waves accidentally high-fiving each other, stacking their heights together to create a much taller peak than any individual wave could achieve alone. Second, second-order bound nonlinearities represent natural wave physics that reshape wave geometry, making crests steeper and more pronounced, while simultaneously flattening the valleys between waves. This geometric distortion can boost large waves by an additional 15 to 20% in height. Fedele clarifies that when these two completely normal oceanic behaviors coincidentally align, the result becomes a significantly larger wave. The nonlinear characteristics inherent in ocean waves provide additional amplification, pushing these formations to grow even more extreme. From academic theory to life-saving applications. But here's where this research becomes urgently practical rather than just academically interesting. Fedele emphasizes that rogue waves pose genuine immediate threats to maritime vessels and offshore infrastructure worldwide. Current forecasting systems often treat these waves as completely unpredictable random events. They represent extreme conditions, absolutely, but they follow explainable patterns, he insists. Upgrading these prediction models isn't just scientifically interesting, it's literally a matter of life and death. Accurate rogue wave forecasting is absolutely essential for safe ship navigation, protecting coastal infrastructure, and ensuring offshore oil platform integrity. Fedele explains, these structures must be engineered to withstand these extreme oceanic events. Fedele's research is already transforming how major organizations approach ocean risk assessment. Both the National Oceanic and Atmospheric Administration and energy giant Chevron now utilize his predictive models to forecast when and where rogue waves are most likely to develop. Currently, Fedele is harnessing machine learning technology to analyze decades of accumulated wave data, teaching algorithms to recognize the subtle combinations of height, direction, and timing patterns that typically precede extreme wave events. His ultimate goal involves providing forecasters with significantly more precise tools for predicting rogue wave occurrence. Nature doesn't break rules, it bends them. The fundamental lesson emerging from this research might surprise you. Rogue waves aren't rebellious exceptions to natural laws. They're actually the inevitable result of those same laws operating under specific conditions. Nature doesn't need to violate its own physics to create something that amazes and terrifies us. It simply needs time and that rare moment when all the variables align in precisely the wrong configuration. Despite oceans appearing chaotic and unpredictable, extreme waves like rogues actually follow recognizable natural patterns. Each rogue wave carries what researchers call a distinctive signature, a structured wave group both before and after the peak that reveals exactly how that particular giant formed. Rogue waves essentially represent the ocean having a particularly bad day, Fedele concludes. They're extreme meteorological events, certainly, but they're written in the ocean's natural vocabulary. We're finally becoming fluent enough to understand what the sea is trying to tell us. But here's where it gets controversial. If rogue waves are actually predictable natural phenomena, rather than random acts of oceanic violence, should maritime industries be held more accountable for disasters that occur when these waves strike? Are we potentially looking at a future where acts of God defense becomes much harder to justify in court? What do you think? Does this research make you feel safer knowing rogue waves follow patterns? Or more concerned that we've been underestimating oceanic dangers for so long? Should shipping companies and offshore operators face stricter regulations now that we understand these waves better? Share your thoughts on whether this scientific breakthrough changes how we should approach ocean safety and maritime responsibility.